Hello YouTube friends and family, I hope you're having a wonderful week so far. So this past Wednesday I spoke at the Android Plus Meetup group in McLean. If you have the opportunity, you should come check it out sometime. But if you missed it, luckily we were able to record it this week so you can watch it here. This week I spoke about machine learning and MLKit. I really like talking about the stuff and I had a lot of fun doing it. However, it's been a little while since I've done public speaking, so this is not my best work, and I'm a little bit rusty. Definitely need more practice on that. And also, sorry about the audio quality, because this is the first time that we recorded it in a situation like that. So we'll work on it, and hopefully you'll get better. But without further ado, here's the video. Enjoy.
Welcome, everyone. This is our first meetup of the year, Android Plus. If you're not on the meetup group, please join it. If you parked here and got a ticket, let us know at the end of the meetup and we'll go validate it for you. Thanks to Capital One for the food and the drinks and the venue. For future meetup, look at our meetup page and we'll be publishing events over there. Today our speaker is Jimmy. He's going to be talking about machine learning.
Cool. All right, thanks, David. All right, hello everyone. As we said, my name is Jimmy Sambu. Today I'll be talking a little bit about machine learning and MLKit. So first, I just wanted to tell you a little bit about myself. So I'm actually an iOS developer by trade, but in my spare time, I like to dabble in a lot of different things, like learning about AI, playing around with VR stuff. Recently, I've been doing more CrossFit and ballroom dancing, and I also type in Dvorak, which is something that a lot of people don't know about until they try to type on my keyboard and realize all the keys are different, and random things like that. I've been developing for 10 years on different things like websites and on iOS. But that's enough about me. So for the first part, I wanted to talk a little bit about machine learning. So some of you might have heard, there's a couple of different things that you might think about when you think about the word machine learning, but oftentimes that's a term that gets thrown around without much consideration and thought about what it actually is. So for the purposes of this presentation, I wanted to give you what I call simple definition. And so what I am talking about when I talk about machine learning is the technique of automatically creating an algorithm or a function, automatically creating or generating that based on a given couple of different samples, data samples, like from a data set, and having that algorithm detect patterns throughout that data set. So not explicitly saying step one, do this, step two, do that. It's automatically detecting the patterns and trying to figure out, building the algorithm that way. And so here's one example where, let's say if for some reason you don't know what a cat is, maybe a baby doesn't know what it is. So you might say, here's an example of a cat. Here's a cat. Here's a cat. Here's a cat. That's a cat, right? And then so we never really defined what a cat is, but maybe you might be able to, in your minds, you're generalizing and kind of learning what it is based on what you see. So maybe a cat might have pointy ears, 2 eyes, a nose. And so if I give you a picture of a completely new cat, or a new thing, I should say, and if I ask you, is this a cat? You might say, yes, it's a cat. You might say, no, it's not a cat. And you'll probably have some confidence level, right? Like you might say, you're like 100% sure that that's a cat. There's no doubt in your mind. Or that might be some other feline thing. It's all based on your experience, but I want to give you a slightly different example because you all probably have this preconception of what a cat is already. So I want to switch to the Chinese language because one of the things I'm also interested in is Chinese and foreign languages. And hopefully, I know some of you know Chinese, but hopefully you don't. And if I told you this is the character for Earth or soil, like that's the character, that's the same character, that's the same character, that's the same character, right? And I'm teaching you this character. But if I bring up this completely new example, you've already in your mind made this model of what this character should be. So based on this new example, you might say, yeah, that's the same character, or no, that's not. And I see some of you nodding. This is kind of a tricky situation because this is actually not the same character. This one actually means like disciple or warrior, I believe, because it's longer on the top. But you wouldn't have known that because I never told you that, or you might have never seen that example. And these are some of the problems that going through machine learning you might have. It's the same thing with human learning, where I only gave you 4 examples, so of course it's going to be really difficult for you to generalize this material. As well as if I had given you an incorrect example of what this character was, that might mess up your your generalization of these characters. Just some of the problems that you'll also see in typical machine learning. So what we were doing there is kind of training your mental model of what these things are. And so when dealing with machine learning and teaching a computer how to learn, teaching a machine how to learn, there's generally a couple of steps. The first one is building that model, that mental model, by training it, by giving it a lot of data from a data set, before you can actually tell it to run that model and try to make a prediction or generate something. So for this first part, I wanted to talk about a generalization of how we train a model. So as I said before, we have our input data. This is generally a large data set, and this specifically is a labeled data set. So you can see here, like that's a cat, and that's not a cat. Generally, these data sets could be really large or up to millions of data points. And they don't necessarily have to be labeled. They could be unlabeled. And they don't have to be images. They could be text. They could be audio files. Any kind of data sources could be used to train a model. Based on that, as well as a learning algorithm, then you'll be able to get out a machine learning model. For the learning algorithm, this is something that you can customly build. This one specifically represents an artificial neural network, which is based on what people believe is how the human brain works with synapses and neurons. And there's a couple of different. That one in itself can take you weeks or years to learn all the different types and such, but in general, I believe there could be about 3 different types, including supervised learning, which is giving data set that are already labeled, or someone could be manually going through the data set and telling you, marking what the data is. It could be unlabeled, so just from a bunch of random images, the machine learning model might try to generalize different groups of things without you saying what the group is. It'll just try to figure it out by itself. That's unsupervised style. And the third style is reinforced learning, which is where you try to give it a target, a goal, to either maximize or minimize. Like, let's say if you wanted to teach it to play a game, like Flappy Bird, for instance, you can say the further the bird goes, the higher the score is, the better. So the machine learning algorithm might try different inputs, like tapping the bird at different times, and trying to play the game multiple times until that score just gets bigger and bigger until it plays it perfectly and it never stops. So with the data and the algorithm, after training it via CPUs or GPUs, that could take a lot of time. You can do it locally on your computer. You can do it on the cloud. But from that, you'll generally get back a model. This is generally a file that you can use to load at a later point to run it on the device or on the back end somewhere, so that you can actually start making predictions or generating stuff. I'll talk about that a little bit more later. But for running the model, it's a little bit simpler. You have one piece of data and you have your model. You apply the data to the model, or apply the model to the data. And in this instance, we're asking it, is this a cat? The output would be, yes, it is a cat, or no, it's not a cat. And sometimes you can also get confidence levels based off of that, saying, this one is saying that it's very sure that this is a cat, based on what it's learned. But it doesn't have to be only like binary decisions, like yes or no. It could also be multiple classification styles. So in one instance, you can say if you're thinking about object detection inside of a picture, you can say, what is this thing in the picture? Is it like a hat? Is it a book? Is it a chair? Like one out of multiple things. That can be done using generative adversarial networks. You can make it generate stuff like, let's say, music. If you trained a neural network with a lot of pop music, let's say, and teach it what pop music kind of is, you can tell it to say, okay, generate me this completely new pop music or classical music out of thin air, basically. Or generating a picture or generating videos. A lot of examples have been done by that. I'm sure maybe you've seen some of these examples on the news, like maybe you've seen someone faking Mark Zuckerberg saying some random stuff on social media, or maybe you've heard of the news of deepfakes. It's probably not really suitable for this discussion. But many things like that can be done. And to do that, there's a couple of different libraries that you can use that are popular today. Most of them are done in Python nowadays, but you can also do them in multiple other languages. And they vary from being a very high-level thing, a high-level neural network API, such as Keras, which with Keras you can actually choose different implementation engines, such as, sorry, I'm jumping all around here. You can choose one of multiple engines to work with. So for instance, you can use TensorFlow, you can use Theanos. I don't know if anyone knows any of the other ones. But from there, TensorFlow is also another high-level API language where you can use to train models as well as execute them. And TensorFlow, and specifically TensorFlow Lite, is the one that I'll be talking about more later, because that's the one that MLKit uses to run on the Android device, or even in the cloud. And finally, another popular one recently is PyTorch. PyTorch is a much lower level API for neural networks. That's if you want more control over what you're doing and want that control. Yeah.
I read an article sometime back that Google integrated Keras in TensorFlow library as well. So you could include TensorFlow and all the functionality of Keras as well.
Yes, I think you're right about that. And for those of you, if you didn't hear, TensorFlow recently, I think it's in version 2, they integrated Keras's API into TensorFlow. So it's much more integrated into each other. Like if you want to use Keras or by itself or TensorFlow by itself, it's kind of intermingled in together. So you don't really have to choose one or the other. It's kind of there together. I think you just have to say like tf.keras. And then you can access all of the Keras API, just because it's so similar in the things that you have to do. So that's if you want to train custom models, but oftentimes you might not want to do that. Maybe you want to use just some pre-trained models, and a lot of those also exist. Here is a screen of TensorFlow. On their website, they actually have a couple of pre-trained models that you can choose from. Some of the examples here include image classification, so showing what's inside the picture, if it's like a plant or if it's a person. Pose estimation, so if you take a picture of a person and they're like standing in a weird way, you can have like a wireframe of their body where their arms are. Or smart reply, so for text, if you want to say what the response should be in a series of texts, there's a model for that. And style transfer seems to be an interesting one, I think. It's where you take one picture and you say that's the style image, like let's say Picasso or some very stylistic photo, and then you take another photo, like a picture of yourself. You can apply the style of that first photo to the second photo, and then have yourself in the style of Picasso or in the style of Andy Warhol or something like that. Any questions so far on the ML stuff? I went through it on a very high level. just to give you a brief intro into MLKit. You guys have any questions or thoughts so far? I'm hoping this can be more of a discussion. So, because as I said before, I'm not a sorry, I'm not sure if I said this before, but by day I'm an iOS developer. So machine learning and Android development aren't what I do full time. So I'm kind of learning this as I go, like on my free time. So I'm hoping that by sharing the stuff that I've learned, and you guys can also pitch in whenever you're on stuff that you have learned throughout your time, and then we can kind of learn together. Is the hope. Oh yeah.
Yesterday, a month back, I used Google Maps. I used a new feature, Live View, where on clicking on object detection of the buildings, and it showed me the path.
Oh, yeah, you mean on Google Maps how they have the AR view, and then they kind of transpose arrows and tell you where to walk right on the... That's a good question. I want to say yes. I don't think any one person can manually map that out.
Yeah, that's so like it's detecting the buildings.
Yes.
And showing us the navigation to the issue.
I think so, and that's probably something. I feel like they're probably feeding in a lot of data of the area around it using the thousands of images that they have of that area, and then kind of teaching it where to put specific landmarks. That's a good point, actually. Didn't really consider that one. Okay, so on to MLKit. So MLKit is actually a Firebase product. How many of you are familiar with Firebase? Just kind of curious. Okay. And it looks like a few of you aren't. So for you guys, Firebase is kind of this product that Google made that helps mobile developers have like a full-featured backend. So things like a real-time database, storage, authentication, messaging, all of those things that you would normally need for a fully featured mobile app. So instead of paying another team to do the backend for you, you can actually just use Firebase and get a lot of that feature in, and even do a lot of that yourself. So it's a really nice SDK and a platform to build your apps off of. And one of the features that they have is MLKit. So specifically, MLKit is a framework or SDK that it kind of bundles a couple of different things together. One of it is the Google Cloud Vision API. So you can hit those and run the APIs off of the Google Cloud. The other is the TensorFlow Lite library, so you can actually work with TensorFlow models. And finally, it's also a wrapper over the Android Neural Network API. And that's a much lower level C++ library. So instead of using that, MLKit is kind of like a wrapper layer on top of that, making it a little bit nicer to use. And MLKit offers a lot of different features, but there's 5 in particular that they like to say that they can do easily. So the first one is text recognition. So if you put your camera in front of, like, let's say a menu or a street sign, then it can actually give you the text that it's saying, otherwise known as OCR. The second one is facial detection. So if I have my camera out in front of you guys, it can say, here's a face, here's a face, here's a face, here's a face in this location. And it can also do things like, I'll show you a demo of this later, but it can also tell you where specific landmark features of your face are, like your eyes, the edges of them, where your nose is, the center of your face, your lips, just a bunch of this data. So you can build your own apps doing things like putting fake glasses on you, or a mustache, or Snapchat style facial AR features. Third thing is barcode recognition. So barcodes, QR codes, just being able to recognize that and telling you what they are. Fourth thing is landmarks. So if you take a picture of something like the Eiffel Tower or the pyramids, then it can tell you what they are. It can tell you where it is, and a lot of information like that. This one's particularly special because you can't actually do this on the phone. This one you actually need a connection to the Google Cloud. I'm assuming because there's so many landmarks throughout the world that you probably can't fit all of that into a phone. The machine learning model would be probably way too big. That's my guess. And the fifth one is detecting what things are inside of an image. So in this case, it's saying there's the sun, clouds, sky, hills, things like that. And I kind of spoke about this a little bit before, but one of the things that MLKit lets you do is run these models offline. So you don't need to be connected to a network. You can actually run like the smart replies or the object recognitions right on the phone. This offers a lot of benefits like privacy. Like you don't need to go through a network. You don't need a network connection, so it's a little bit faster. Let's see, there's privacy. Oh, there's cost. Thank you. Yeah. So you don't have to keep a server in the back end running. That can get kind of expensive. I think there's a couple of other things. Not too important right now. The other way you can do it is running the machine learning model on the cloud. So you can have a server that maybe one of the APIs is you can send it the photo and then it can run it through the model on the cloud and just return the results back to the phone. This also has its own pros and cons. It costs a little bit more money, but it allows you to run much bigger models without putting that onto the phone. So maybe for slower devices, if it can't run a model really fast, it might be faster just to send it over the network, have it run on the server, and then return the results that way. MLKit allows you to pick between the two. And by being able to run on the cloud, another feature that they have is the ability to update the model on your device without having to launch a new version of your app. So one thing that you can do is, let's say you're developing an app that has ML capabilities. You can load the model right inside the app, so that when you launch your app, everyone will already have the model. But if you ever want to update the model again, generally you'll have to release a new version of your app with that new model. But Firebase has this capability where you can just upload the model onto their console. And the next time someone starts up your application, it can go and check Firebase and say, oh, there's version 2 of your model. Just download it, and everyone will have the updated version of the model. That's something MLKit offers. And they say it's pretty simple to use. There's generally only 3 steps. One is integrating the SDK. It's really just the Firebase SDK. Preparing the input data, so that could be getting data from your camera or from like a text message or something like that. And then finally, taking that data and just applying the model onto it. It's really that simple. And I have some code here. I'll quickly go over it because I'm not sure how interesting this part will be. But it's not that bad. So in this one, there's only really 2 lines of code. First, you have to load the model, right? And they have their own Firebase. In Firebase, you have a couple of different classes that you have to use. So in the first part here, we're selecting the model using a Firebase custom local model. By the way, in these examples, I'm loading in a custom TensorFlow Lite model. Like I said, Firebase does have its own pre-trained models in there. But if you want to load your own custom model, you'll select it from using a file path using the Firebase custom local model class. And then you can put it into a Firebase model interpreter. From there, you'll end up with what they call an interpreter. So from there, you'll have an interpreter. And you'll need 2 things before you can actually run this interpreter. The first thing is the inputs, which is what they call Firebase model inputs. In this case, we're adding image data, like if you take a picture of your face, for instance. In order to pass that in, you kind of need to store that into the inputs and hold that as a variable here. And the second thing is you need options. I'm going to assume this is really too small for you to read, but the most important part here is it's specifying the data types of what the input is, what the output is. In this case, it's going to be an array of bytes. And I think that's the most important part about this, just specifying what the inputs and outputs are. But there's a lot of other options you can also do. And finally, you just run the model. So with the interpreter, you call the run function, passing in your inputs, as well as the options. And this is a coroutine, so you can put a continuation there. From that, you can pull out the output using what you get back from the coroutine, pulling out the results, casting it as, in this case, we're doing it as a byte array, and doing some processing on that. I'm skimming over this, by the way. Doing some processing on that to get back a string, an array, a list of strings, so that you can do something like put it on top of your image or log it somewhere, or do whatever you want with the output of the model. And you also have to put it, as a small note, you also have to put it around try-catch blocks, because sometimes the model might fail for various reasons. Okay, and the demo part of this. Okay, so Firebase has this nice sample project. Well, I can't find it right now, but they have this nice sample project that has basically all of the models, the pre-trained models there, so you can look at the code and run it in both Java and Kotlin flavors. So if you compile it and run it, this is what it looks like. And I'm just going to hit the Kotlin one. It's both the same, really, using the live preview activity. And what this will allow you to do is, so I'm going to do my face, so just in case you guys don't want to be on camera. So this one is using the face detection mechanism, specifically face contour. You can see on screen there's a lot of, I'm going to sit down and face some for you. So this one's using the face contour, and as you can see, it's detecting where my face is in real time with a bounding box. So you get that data as well as a bunch of different points marking where my face is, where my chin is. You can see as I'm talking, it's also detecting where my lips is, where my nose is. There's like a point right here to show the middle of the face, as well as the eyes. A lot of data points there. Another interesting one is object detection. So object detection is having it tell you what's on screen. So let's say, okay, see, so it detects there's an object and it's unknown. Oh, see, so it thinks this one's food. But it's only 50% confidence. Maybe. Well, it could be food. So that's not really, okay, what about this? Oh, what about this? Okay, so I guess it's not really accurate, but it probably needs a little bit more training in order to be more confident about it. Oh yeah, sure, let's try that. Fashion good. 73% confidence. Okay, so maybe this is not one of the best models that they have here, but there's another one here called label detection. And if you try that out, so this is the one that actually tells you what is in the images. So here, so it can detect that there's like a table. It's jumping around a lot, but there's a desk, there's a chair. I have to detect the pen. Maybe it can detect, I think there's a musical instrument there. Okay, not too accurate either, but you can imagine using this for things like making applications for people who are visually impaired and you want them to read out what the camera is seeing, or maybe automatically putting a caption on images on your website without having to manually type it, so you can take some of the keywords and have it string together a sentence. If I flip it around, I think it might be a little bit more accurate. So it knows it's like a selfie, yeah, it detects ears, eyelash, necklace. So kind of accurate there, although it's saying like hat a couple of times, but I'm not wearing a hat. And yeah, there's just a lot of other things, text detection, as I talked about before. So I can read, see it says 0 sugar, calories, cola. And you can probably notice that it's jumping around a lot, and this is because it's running the model multiple times every second. So you probably just want to get one snapshot. This is, I believe, running offline, all on the device. There are a couple of models that run on the cloud. I don't see it right now, but I think Auto ML Vision Edge should be running in the cloud. Maybe, no. So Auto ML is on Firebase. It's a way for you to give it your own images and allow you to train like what custom objects are. And it might be on the phone. Sorry, I'm not too familiar with that. You might be right, although it kind of just froze my phone. And barcode stuff. There you go. That's kind of accurate. So that's some of the features that you can do with MLKit. And as I said before, this entire example they have on a quick start on their repo on Firebase/quick start. The entire code base is there for you to look through, both Java and Kotlin. I'm showing you all of these different examples, and in case you're wondering how to implement it. The question is, how do I integrate Firebase into the iOS apps? So with Android, it's pretty similar with Android. With Android, you just implement, you add the Firebase SDK into the Android application, and you just start using the classes. On iOS, it's very similar. I believe if any of you are iOS developers, I believe they use CocoaPods to download the framework into your iOS app, and then from there, just start using the classes, very similar to Android. I assume. I only looked at the Android one actually, but I'm pretty sure that's what they do. Okay.
How long does it generally take to, how many points of data do you need to actually train and do something?
That's a really good question. The question is, how many data points do we need to actually train a model? I believe you don't actually need that much. Like something even under 100 samples could be doable, but you always run into the potential risk of not having enough training samples and having it mispredict what a lot of different things are. So if you have a lot of edge cases, it probably won't be that accurate. I think in general more is better, but then again, the more data samples you have, the longer it takes to train the data, and you might. Sorry, I'm thinking about a lot of different issues that comes up with that, including potentially overtraining your model, where if you get, depending on the data sets that you have, if it's too similar to one thing, you might overfit the model into that specific sample. So, like, let's say if I just took 1 million pictures of my own face and saying for a facial recognition system, and then I created a model out of that. If I started like taking pictures of other people's faces, it might not know because it's only trained on my face. I hope that answers your...
Yeah, that answers the question. I have one more question.
Yep.
So the difference between stuff on the phone and stuff on like the cloud or whatever, it's the same code, it just has less like RAM, right?
I believe it's the same model and the same... It should be the same... yeah, the same logic, the same memory requirements, I believe. Because in the end, you're ultimately running a TF-Lite model file. well, I guess you could run other models, like if you're using Keras or PyTorch, because those you can't run on the phone, at least not with MLKit. So if you do choose to run it in the cloud, you have more options of different frameworks to use.
Okay, because I've noticed that sometimes when I'm running stuff like this, it works a lot better than the internet. I was just wondering if the internet had more RAM or more power, or is it just like running a better model?
So yeah, continuing that, if the cloud is able to run with more RAM and more power, that is true. And as I mentioned earlier, the landmark detection feature, where if you take a picture of a certain landmark feature, that one specifically can't run on the phone because I believe the model is probably too big to fit onto the phone, and it would probably take too long to run, too memory intensive. So I think you're right about that. That's probably why they can only do it on the cloud itself. Although I believe they're continuously, like, the technology that they have is able to make it so that model is getting a lot smaller, and then of course phones are becoming more powerful. I believe in one of the Google I/O conferences, they made an announcement where I think this was the first time that they said that you can start running machine learning models on your phone, and it was just so much faster. I think it was like last year. Remember the announcement? Yeah, running TF Lite files. So maybe one day you'll be able to run landmark detection all on your phone. And I think they said it shrunk like the data from 10 gigabytes all the way down to like 100 megabytes or something crazy like that. Yeah, it's crazy stuff. So I think there's just one more thing I wanted to show you, and that would be the Firebase console. Here it is. So if you've never seen Firebase before, this is what it looks like. As I said, using Firebase will allow you to put things like authentication, database, storage, hosting, all for your app, all in one place. And here you can see this is the MLKit portion of it. From there, they have a couple of different APIs for you to use. Like I mentioned before, the text recognition, face detection, all the good stuff. As well as, if you hit custom here, this is where you can host your custom TensorFlow models. This is one that I just added. But let's say if on the phone, if you're saying use this model, you can reference it by name. And then if I ever want to update this model, I can hit replace the model and just upload a model file here. That way, whenever everyone else opens up their phone, they'll get a copy of that new model. As well as something called AutoML, and I believe that's where you can upload pictures of custom objects. Like let's say if you have some really custom thing that you want to identify, and you don't want to do a lot of the training yourself, you kind of want to just offload it onto Firebase. Firebase will allow you to do that and offer you the API to make it detect, I don't know, maybe like a custom variety of plants, or maybe a specific car model or car feature.
Like when people are using their phones and it's running on models are running on the phone, are the models learning anything on the phone?
Oh, that's a good question. So the question is, when running the models on the phone, is it learning anything?
Yeah, like is the phone like getting better at looking what the person is looking at?
Right.
Therefore, you can like maybe take that and add into your.
Yes. So I believe with MLKit specifically, it isn't updating the model as it runs. However, I want to say I don't know if this is in the world today. I feel like a lot of people are. There may be models out there where it's doing exactly as you said. As it's running the model, it gets better and better. The difficult part is depending on what you're doing with that. Like let's say if you're doing object detection, sometimes it's not really possible to update the model because if you're updating the model, you need to give live feedback to it, right? So somehow you need to go into the app and say, yep, this is correct, this is not correct.
Okay. So it's not getting validation.
Yeah. If you don't provide the validation, then that's not possible. But as I said, with TensorFlow Lite specifically, and MLKit, I believe that's not something that can happen.
Yeah, I was going to say, I think there's an option on the iOS side with a similar thing where the models are pre-trained, but they're going to be kind of
pre-trained in a category like image detection, and then you would add, and you could say, oh, and I'm like, there's some other, or I'll say object detection, right? And so kind of generally knows, like, I don't know what foundationally kind of makes distinctions about boundaries of things and so forth. And then, but you could append to it, if you will. It's more limited in terms of what it can learn and that kind of stuff. But I think that's starting to be available, right? So you have a pre-trained thing, and then you can add a few more options or add a few more cases that will help it. Yeah. But it's usually computationally expensive, so.
Makes sense. I haven't looked actually too much at the iOS side of things.